All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So all we're doing on this is saying let's find y bar. What's the y coordinate of our centroid, of our object? So if we're doing our centroid, also I've given a table here that has centroid info. So it's our area, x tilde, y tilde values. So we can try to work through that. And I've taken out, or I've only put in the pieces that we're going to work with in here. So let's try to come in and first say, how do we split this up into shapes I could work with? There's a lot of valid ways we could do this. I would say, well, I have a 12 plus 5 plus 8, a 25 by 10 rectangle. I'm going to call that shape number 1. So shape 1. Then I could come in and say, I have a positive shape right here, a triangle. Let's call this shape 2. A semicircle here. That'll be shape 3. 3. And then a hole that we're cutting out. A full circle, shape 4. As we're setting up these pieces, this is probably the easiest way for us to tackle that. I've seen people on this exact problem go shape 1 is 12 by 12, shape 2, or 12 by 10, shape 2 is 5 by 10, shape 3, 8 by 10, and make this 3 pieces. And then come into this circle and say, oh, let's make 2 half circles in there. And it just balloons into more and more work. We can do this in just 4 shapes. Get in, get out. We also know if I'm making a centroid problem, probably the easiest way to solve this out, if it's more than like 1 or 2 pieces, is to make a table for it. So let's make our table. What are we working towards? Ultimately, for y bar, I know this is the sum of my y tilde times the area divided by the sum of all of my areas, sum of my A. So that's what I need to get towards, which means I need a table that's going to fill in each piece in there. What's my area, y tilde A. So let's come and start making that. What's our shape? We'll get a column for how are we naming everything in here. That was working a lot better. Shape. And we can put in next to that, we'll get a column for each of those. So shape 1, 2, 3, 4, and we know at the bottom, I want to sum some things up. So we stick in a summation row. Then I need a column for what's my area? So area in inches squared. What is my on the numerator, I need y tilde. So what's my y tilde value? And that's going to be in inches. And then I'll multiply those 2 columns together to get a y tilde A in inches squared times inches cubed. So we can work through those. And I know I don't sum up my tilde distances, but everything else I do want to add up. So let's come in and just go for it. So that shape number 1 we said was 25 wide, 10 tall. It's a rectangle. The area of a rectangle, which is base times height. 25 times 10 is 250. My y tilde value in here, we're given that it is half the height into that. So I need to first get to the bottom of that rectangle, or the top, either one I could work with, and then go halfway into it. So I'll come up from the bottom of my entire object, from the x-axis. If I go up 6 inches, I get to the beginning of the rectangle, and then my centroid formula applies. Plus the height over 2, or plus 10 over 2. This is 11. 250 times 11 is 2750. Shape 2, we had a triangle. The area of a triangle is 1/2 base times height. We have that in our table if we forget it, base times height over 2. But my base here is 8, my height is 6. 1/2 of 8 times 6. Well, 6 times 8 is 48, divided by 2 would get me 24. My tilde distance should measure from the flat side, or the bottom, the flat x side of my triangle, 1/3 of the way into it. This is oriented differently. We're coming from the 90-degree angle. I need to get up to the 90-degree angle in that triangle, up to there. So I'm going to go up 6 and then come back down. 6 minus a third of the way in. 6 minus 6/3. That's the same thing as 2/3 from the pointy side. From the bottom here, 2/3 in. Either way, 2/3 is 6. 6 minus 6/3 is 4. 24 times 4 is 96. For shape 3, we're looking at a semicircle. So the area of a semicircle should be pi times our radius. The radius on this is 6 inches. Pi times 6 squared over 2. Or that's going to get us 56.55. My centroid of a semicircle measures from the flat side of it into it. So I need to first get from the x to the flat side. Or I go up the radius, so 6. And then I come back towards my x-axis, so I'm subtracting distance off here. And I just grab my centroid formula, 4r over 3 pi. So 6 minus 4 times the radius is 6, r over 3 pi. 4r over 3 pi. Or this is 3.45. 56.55 times 3.45 gets us 195.29. 195.29. And one last piece for us to get. We need to work with my full circle, shape 4. The area of a circle is pi r squared. There's a hole, so negative pi times my radius. We're given that radius is 4 inches. Pi times 4 squared. This is negative 50.27. My centroid of this, it looks like it's not giving us one. That's because our key axes go straight through the centroid. We're going dead to the middle of our circle, hits the centroid. So the middle would just be this 6-inch radius up, gets me to the middle. I'm at 6. Which negative 50.27 times 6, don't forget we got a negative here, is negative 301.6. And I need to add up my first and last column in here. My total area is 280.28. And my total y tilde a is 2739.69. 2739.69. Which basically finishes our problem. I can come back up and do one last thing to get y bar. Y bar is y tilde a, 2739.69, divided by our total area, 280.28. 280.28. Or solving that out, y bar is 9.77 inches. Y bar is 9.77 inches. Which if we stop and logically think about that, does that answer make sense for us? If I asked you to balance this paper, if this was a piece of paper and I asked you to balance that shape on your finger, would you stick your finger 9.77 inches up, somewhere right around here maybe? That seems pretty reasonable to me. I would believe we're at least ballpark correct. Don't be the person who comes in and says, oh, the centroid is at like 16 inches. That's at the edge of this. Definitely not beyond 16. Or that tells me like, oh, it's a 1/4 of an inch up into this. That can't be true either down here. Logically, that's obviously wrong. If we were to try to balance that, we can guess pretty accurately where intuitively we think it should balance at. We're just getting the engineering behind it to the exact point that it should balance at. But gut check your answers on these. It works great for saying, does this logically make sense? You still might have mistakes, but it's going to catch any huge ones that you might have in there. But we'll wrap up the problem there. Hopefully this was a useful video for you. If it was, hit our like and subscribe buttons. Watch more videos. Let's get you in A with JJ.